to another Greenville County Library System virtual event. I'm Rachel, and I'm the Adult Outreach and Event Coordinator for the Library System. I'm so happy to see you all here, and I'm looking forward to this exciting program, Unsolved Mystery: Is There Life on Europa? This is our last mystery event in our month of mystery, and what a way to end by discussing the mysteries of space. If you missed any of the other ones, be sure to go to greenvillelibrary.org. You can check out the adult classes and activities page, and that way you can look at our YouTube playlist so you don't miss out on any of these fun events. If this is your first time using Zoom, be sure to familiarize yourself with that mute button. The bottom left of your screen, you'll want to stay muted while our presenter is speaking, and then you can unmute towards the end if you'd like to during Q&A. Be sure to use the chat feature at any time to ask any library related questions, technical questions, or questions for the presentation. We'll be answering questions throughout, and we'll also do them during the Q&A. So anytime you'd like to pop a question in the chat, feel free to do so. Now I'd like to introduce tonight's NASA Solar System Ambassador who's going to be speaking for us. David Leapart entered the space age at the time of the Mercury astronauts by founding and leading the Lockheed Model Rocket Society. He obtained 2 degrees in physics and did research in planetary orbits around binary stars. He taught astronomy in graduate school and was a student director of the Melton Observatory in Columbia, South Carolina. His professional career was mostly computer networking, but he did work at one point with MIT and NASA to use his physics training on aviation safety and early GPS for small airplanes. He's continuously involved in programs to educate and inspire the public on space science, its exploration, its discoveries, and its impacts to all of us. He is partnering with local organizations like the library, and he does that so that he can engage many people in discussions on astronomy, space exploration, astronautics, and NASA activities. He currently conducts astronomical endeavors through his personal observatory, Cedar Grove Observatory. So please join me in welcoming David Leapart.
Hello, everyone. Nice to you've with us tonight, and I have a really fun subject to talk about, and this is probably my most favorite thing in space science, is the moon Europa. Extremely special, and you'll see why. It's probably not something on the tip of your lips or something that you've even thought about, but hopefully after tonight, you'll get an idea of what's going on. I'm going to share my screen here. Um, Here we go. And there we go. Okay. Is there life on Europa? This gets back to some of Rachel's programs in terms of mysteries and mysteries for the month. And this is going to be our unsolved mystery for tonight. And is there life on Europa? Being careful when I say life, I don't mean people or even fish, but life, some kind of life, microbial life, etc. So that's kind of where we are. So let's start off. I want to give you a little food for thought. And there's a famous quote that I really love, and it's from a fellow you may have heard of, Albert Einstein, and it's the most beautiful experience we can have is the mysterious. It's the fundamental emotion that stands at the cradle of true art and true science. It's You can see where mystery can inspire us in many ways, not only from a scientific, technical perspective, but how many great artists have also been inspired by the mysterious. Okay, so that'll give you something to think about. Rachel has already done a good job at this. This is just a real quickie on myself. I work as part of the NASA Solar System Ambassador Program, and this is based out of the Jet Propulsion Laboratory out in California. And if you're not familiar with what we call JPL for short, uh, all of the recent endeavors, uh, pun intended, with and perseverance with the Mars rover and the helicopter and all that, is a lot of that is based out of JPL. So the JPL is one of the NASA locations really involved with planetary exploration. So it's one of their major centers there. So let's take a look at Europa and see if this is going to look a little strange to you. There is Europa, courtesy of the planetarium. And you notice it doesn't look like probably much anything you've ever seen if you have not really looked into this. It doesn't look like the moon. It doesn't look like Mars. It doesn't look like Earth. It doesn't look like anything. It looks like Europa. And it's this sort of very light color with all of these lines and grays. It's not as red as Mars, you might say, but it's kind of a tan color. Let's take a little better look at Europa. So you can see a little better. You can see where it's covered with all of this reddish kind of tannish stuff and all of these lines. And then you can see in between the lines, it's kind of whitish, etc. So I'm going to explain kind of what that is, but this is the moon Europa. This is where we're going to explore tonight. So when we're all said and done, you'll all be experts on Europa and why we're so interested in Europa at NASA and in the space program. Let's start off, and I'm going to basically pose 7 questions on Europa. And these are the questions. And if we were doing this live, I would probably have everybody participate, but it's a little tougher on the virtual. So I'm going to pose the question and then I'll turn around and answer it. So, why is the moon called Europa? Where in the world did they come up with that name? And it goes back into mythology. Europa was basically the mother of King Minos of Crete. She was a Phoenician princess of Argive origin, or namely being Argive origin, she was from the Greek metropolis of Argos. And so she's the mother of King Minos. And here's something, a little tidbit trivia you may not realize, is the continent of Europe was named after Europa, this mother of King Minos. So now you know where the name Europe came from over across the ocean. The moon itself was discovered by Galileo all the way back in 1610 with his little microscope of about 3 inches, but he was able to detect essentially 4 of the moons around Jupiter that are big enough to see through a small telescope. And just another little tidbit, of course, the latest count of moons around Jupiter is around 72. So those have been discovered in many, many ways, both telescopes and also spacecraft. But he discovered the first 4 big ones, and Europa was one of those 4. What's its size? You think, well, here's a moon and it's orbiting Jupiter, and how big is it? How far away is it? And if you have seen any kind of pictures of the solar system, you realize Jupiter is the big, massive planet that's part of our solar system. It takes about 30 Earths just to go across the diameter of Jupiter. So it's massive, and it has all of these moons. So here's Europa. We've seen the picture of it there with all the lines on it. There's your size comparison. You can see there's Earth, here's our moon, and here's Europa. So you can see it's not quite the size of our moon, just a hair smaller, but it's about the size of our moon is the easiest way to think about it. So we're very familiar with seeing our moon in the sky, etc. So Europa is about the size of our moon. The distance from the sun is 5.2 AUs. And you say, what the heck is an AU? AU stands for astronomical unit. And what that means is that the distance from the Earth to the sun is 1 astronomical unit. So if the distance from the Earth to the sun is 1, the distance to Europa is 5 times that. So Europa is 5 times the distance that the Earth is from the sun is 5 times the distance from the sun. So it's at 5 AU. So now you've learned even your astronomy for tonight. So you're all going to be Europa and astronomical experts. Question 3. What is the orbit and rotation of Europa? How, how does the orbit work, and how is as it rotates, just like the Earth rotates as it moves around the sun? And in this little diagram, you'll see Europa here orbits. Here's Jupiter, the planet Jupiter, and here's Europa as the moon. And it goes around the planet every 3.6 days. So this little guy is flying. If you think about our moon, it takes roughly 29 days to go around the Earth, which is why the our calendar is divided into 12 months, month. Think of the word month as month, which is where it comes from. The month concept came from the fact that it was tied to the rotation of the moon around the Earth. So each month is one full cycle of the moon. Can't do that with Europa. It's flying around at 3.6 days. It will make one full rotation. See, two of the other big moons of Jupiter, Ganymede and Io, they're also flying around. Ganymede at a pokey 7.2 days, and Jupiter at Io as 1.8. So it's really flying. As a matter of fact, if you have a telescope and are looking at Jupiter in the sky through your telescope just in your backyard, say you look at it through your telescope at 8 o'clock at night, and you look back through your telescope at, say, midnight, you will actually see where Io has moved. So you can see Io very clearly in just a backyard telescope, and you can actually watch it move over some time. That's how fast it's moving. This is a diagram of the various objects in our solar system. And I'm going to teach you another astronomy term called obliquity. Obliquity is how much it's tilted away from being straight up and down. So let's look at Jupiter itself, 3 degrees. So it's basically straight up and down in terms of if the sun were over here, it's straight up and down. So it's kind of facing the sun. The Earth is actually tilted. So when we rotate, we're actually tilted, which causes our seasons. If we weren't tilted, we would have no seasons. If you're on the equator, it would always be summer. If you're on the north, if you're on the poles, you would hardly ever see the sun. But thanks to the tilt of the Earth, we actually have seasons. You can say Mars is about the same. Since Jupiter is not tilted in relative to the sun, Europa has no seasons. The equator always points directly at the sun. It doesn't move around. So there are no seasons. The other fact about Europa is the fact that it's also, when it goes around Jupiter, just like our moon, it's what's called tidally locked. What that means is that if you're standing on the surface of Jupiter, just like you're standing on the surface of the Earth, you always see the same face. So if you go out and you watch the moon as it moves through the various nights, you always see the same face of the moon. You never see the other side. As it goes around, it's locked such that you only see one side of the moon. Same thing with Europa. Standing on Jupiter, you would only see one side of Europa. So it's locked into its orbit. So that gives you some astronomical technical facts on Europa to kind of get you a little oriented there. What's its structure? What is it? Is it a big ball of dust? Is it a big ball of rock? Is it a big ball? Is it just a big nothing, big gas ball? No, it's actually very structured, very similar to our Earth, except for one big deal, which I'll show you in a second. But we believe Europa has an iron core in the middle of the moon, just like the Earth basically has an iron core. It has a rocky mantle. So surrounding the core is dirt and rocks and all the stuff, pretty much just like the Earth. And here's the big deal. It has an ocean of salty water. And The big deal is the amount of ocean or water in this ocean is more than the water that's on Earth. So Europa, even as small as it is, has more water on it than the Earth does. That is absolutely mind blowing. The big difference, though, unlike Earth, is that it lies beneath, because it's so far away from the sun, it's extremely cold out there. It lies below a shell of ice. There's an ice shell that covers the planet around 10 to 15 miles thick. So it's really thick. And then the ocean itself has an estimated depth of 40 to 100 miles. So imagine the ocean that's 100 miles deep. So, I mean, that's a lot of water. So the big deal here is that it's covered in an ice shell, and underneath that ice shell is this salty water, liquid ocean with a rocky mantle and then a core. Due to interacting with Jupiter as it goes around Jupiter, the gravity between the two kind of twists and turns and does all these crazy things to Jupiter. And what happens is it warms Europa up such that we believe this ocean of salty water is actually somewhat warm. It's not really it has the ice above it, but the ocean itself has a kind of a warm temperature. We're not exactly sure exactly what that temperature is, but it's warm enough that it's actually liquid water and not ice. To give you another little picture of this, you can see that the core of the moon is an iron core with a fairly big rocky mantle, lots of dirt and rocks and all that kind of stuff surrounding the core. This blue piece in the diagram, there's the ocean. That's the salty water. And then we saw those earlier pictures of Europa with all the lines and all on it. That is ice. So the whole surface of Europa is an 10 to 15 mile thick covering of ice. Now, if you think about our moon is a big dirt ball and with craters on it and everything else. There is no dirt here. This Europa is completely covered in ice. And these lines that are all over Europa that we saw in an earlier picture are cracks in the ice. So they're called linnae. That's basically they're cracks in the ice, and that's the reason they have all these lines and all around it. So it's very similar to Earth, except exactly the fact that it has this ice crust is massive. That's a huge difference.
David, we have a quick question from the last slide.
Oh, okay, very good.
So why is the
I
tilt,
can go back.
yeah, the one before that one, sorry.
Oh, the one before that. Let's go back. That one.
Yes.
Okay.
Why is the tilt slash obliquity of some planets tilted while others are straight?
It's the theory is, and we're still learning an awful lot about solar system, how solar systems come to be. But a lot of it is based on the fact that when the solar system is very young, you have your star forming in the middle, and you have a big ring of dust around that early baby star. And in the ring of dust are little eddies of currents, and dust and rocks are flowing around, and they're coming together and sticking together due to gravity, and they get bigger and bigger and bigger and bigger. And pretty soon you have planets and asteroids and all coming out of that dust. So a lot of depends on how that stuff comes together. Like in, let's see, what's a good one? Well, look at Mercury. Mercury is almost straight up and down and relative to the sun. When that formed, it formed very cleanly. And so when it's rotating around and forming, that's how those currents were going. If you look at Earth and Mars, we're tilted. So there could have been currents such that it wasn't exactly straight with the sun. So it kind of depends on how these things come together and stick together. Same thing with Neptune out here. Saturn is also kind of tilted pretty much like us. So it was kind of coming at an angle. The weirdo out here is Uranus. Look at this goofball. It's completely on its side. It's turning, so its south pole actually faces the sun, and its north pole faces outside the solar system. This is the weirdo, and we think that the reason this is that something smacked the fire out of it way back and knocked it over on its side. And so that's the reason it's over on its side. The other weirdo is Venus. Venus is actually rotating the wrong way. It's going this way and it's tilted back opposite from, you might say, compared to the Earth. Again, we feel like something hit Venus and changed its tilt and changed its rotation. So it depends on how those eddies and those currents of dirt and dust and how they've come together kind of generated how it might tilt or it may not tilt. Hopefully that helps.
That's great.
Okay.
And then we have a question for your next one.
Okay.
How,
Let's go
yeah,
this one.
perfect.
Okay.
How do we know that Europa has an iron core, rocky mantle, and salty water? Has it ever been explored?
Yes. We have had Galileo and Voyager and all have done some flybys by Europa. So the pictures that you saw early on are actual pictures of Europa. It's not an artist illustration. And the way you can tell, there's two things. One is, how do you know something has an iron core? And what you do is when a spacecraft flies by a planet fairly close, you can track very accurately what the path of the spacecraft is. If it has an iron core, the gravity is going to be a little different than, say, a nickel core or another kind of core. And so, based on the way the orbit and the path of that spacecraft takes, you can derive back what kind of core the planet has. The same thing for the rocky mantle is we know how big it is and we know how much the planet weighs because we can do that from with mathematics and we can get the density. And we know from the density, it rocky mantle, where if it were all gas, say like your Jupiter and Saturn themselves are just big gas balls, they would they would almost, if you could do this, you can't because they're massive. If you could take Saturn or Jupiter and put it on a bed of water, it would float. So Jupiter and Saturn are extremely light. Europa would sink to the bottom. It's got an iron core and a rocky mantle, just like the Earth. So a lot of that is derived from spacecraft that have gone by. You study how the path of the spacecraft goes, and you can derive them back. What's pulling on it? What's tugging on it? And then also you can determine that from taking some of the measurements and knowing what some of the elements are that's making the planet up. So yes, so that has been explored. Galileo and Voyager were the two big ones, and I'll save some thunder to the very end because you'll see some more exploration that's going to be coming up.
Fantastic. And one more question.
Sure.
Do you think the Jupiter facing side of Europa is thinner than the far side?
Is it thinner? Did you say?
Right, thinner.
Yeah, it's there's going to be some extremely it's Jupiter so big, just like with the Earth, you have tides on the Earth. So you have high tide. If you live at the beach, you have high tide, low tide, and those are the impacts of the moon tugging on the Earth. And so you have more at the center than at the top. And so with the side facing Jupiter, you're going to be pulled more. So the idea probably is it's thicker on that side and thinner on the other side. That we don't have really good data. That's part of the mystery of Europa is to see how that thickness varies. But more than likely, due to the physics of it, you're going to be thicker on the side facing Jupiter, thinner on the side facing away from Jupiter. And so and that's kind of the same thing with the moon is its crust varies in thickness based on whether you're on the far side or the near side, the one facing the Earth.
Great, thank you.
Okay, here we go. So again, getting back to what is the surface of the earth is obviously dirt, mountains, and water. If you look at the earth from space, you'll see all the nice blue water, you'll see dirt, you'll see mountains, etc. If you look at the moon, if you look at the moon at night, you'll see craters. And if you look at it through a telescope, you'll see mountains and dirt. Mars, same thing, mountains and dirt. Not Europa, it's ice. All ice. There is no dirt. There are no mountains. It's all a big ice shell. And as I mentioned earlier, it's crisscrossed by all those lines, and those are cracks. And if we go back, I'm gonna go back one slide. I think, yeah. If you see the cracks, but also it's these kind of tan color. The cracks aren't just blue or something. They kind of got some tan, and then you have these areas here that are kind of tannish. Say, well, what's going on there? We think maybe that might be a little thinner part of the ice. Ice might be a little thinner there. What's happened is coming down from the bottom of that ocean are salts and sulfur compounds are coming up from the water and hitting that ice. And where there's a crack, it may actually kind of filter through that crack, and these salts and sulfurs are coming through. And when sulfur compounds are hit by sunlight, they turn tan. And so that's why we think that's tan. That's a lot of sulfur and salts coming out of that water, and then modified by radiation. So that's kind of where all of that kind of tannish color comes from. We think it's primarily sulfur and some salts. If you were standing on the surface of Europa, it would probably look something like this. Now, this is an artist illustration. This is not real, but we feel that this is about, if you were standing on the surface of Europa, you would have some, crusty kind of stuff going on here with ice. There might be some ice cliffs and that kind of, not really mountains per se, but it's all of this is going to be solid ice. I mean, it would be very surreal to be standing there. So I always kind of like this picture. It's nothing you think about in terms of planetary exploration, because if with all the publicity about Mars, you look at pictures of Mars and there's dirt and mountains and rocks and stuff. Europa is totally alien. It's just a big ball of ice, which is really fascinating. Is to when we can get closer to it and actually I would love to see a real picture of this instead of an artist illustration, and really see what it would look like. It'd be really fascinating.
We have a
See, here I
couple.
want to show you. I'm sorry, another question?
Yes, sorry.
No, that's good.
Um, okay, so the Earth's core sometimes causes movement on the surface, such as moving tectonic plates and volcanoes. Do
Right.
Earth and Europa have a core made of similar materials? And do they behave similarly?
The current thinking, and as much as we've been able to find out, we believe that Europa does not have tectonic activity. Uh, Same thing with Venus, for instance, we believe does not have tectonic activity. So we believe that it does not. The one thing that it does have, which is very unusual, and would be due to the iron core, it has a little bit of a magnetic field, which is really interesting. A lot of the moons do not, but that is more evidence of that iron core being there in the middle of Europa. But we'll know more. But at this point, we do not believe it has tectonic plate activity.
Okay, and then the next question is, does the rocky sphere move relative to the ice shell?
Let me go back one right here. The rocky mantle.
Mm-hmm.
It's the mantle itself, again, with not having tectonic activity, probably not. There probably, you notice the water it comes down and hits the mantle, just like at the bottom of the Earth's oceans. If you go to the bottom of the Earth's oceans, you got the rocky bottom, and then the water there. But as far as movement, we don't think so. One of the things that would be really interesting to explore is to see if there are Europa quakes. We don't think there would be, but you never know. We're always surprised, but we don't think so. That would be evidence of that rocky mantle, like you say, maybe moving or twisting. Um, my own thought is I think there probably are some minor rocky mantle generated quakes, probably because the planet, as it goes around Jupiter, is pushed and squeezed by Jupiter. Jupiter is so massive, the gravity is just squeezing and contracting and expanding and twisting and turning on it. Those kinds of activities could possibly generate quakes and cause that mantle to kind of move around and bump a little bit. We just don't have the information right now to know that for a fact. If we can get there and explore more, maybe we'll find some Europa quakes.
Great. And then one last question on this topic. Would the
Sure.
surface be salty too?
More than likely, yes. It's because this, let me go back to, up, we were there. Uh, the water that's here is, as we understand, is salty, full of sulfur and other compounds. The ice, as we understand it, was made from that water. It's the frozen top part of that water. If we could move Europa in closer to the sun and have it thaw out a little bit, it would be a completely ocean covered planet or moon. The reason it has that ice crust on it is because it's so far out and it's so cold. You're going down to like 200 degrees below 0 Fahrenheit out there. So it's cold. So that top part of that ocean is frozen. So probably so, yes.
All right. And do we know how the salination of Europa's ocean compares to our own oceans?
That is, there's been some initial evidence. And the reason we even know that it's salty is that there's geysers on Europa. There's enough of a crack, and I think I actually have a little segment coming up, but there's enough ice cracks that the water can actually come up, and just like Old Faithful out west, the water actually shoots out, and you get a plume of water which immediately disperses. And what we've been able to do is analyze that plume, and so we can determine from that how salty it is. But it's very imprecise right now. Uh, you'll see coming up is that the best thing we could do would be to take a spacecraft with the right instrumentation on it and fly it through one of those plumes and have it sniff that plume and take the water and then analyze that water directly. Then we would have a much better um, feel. But we initially, right now, we feel it's around the same as the Earth's salinity, but it's very imprecise. But it's probably close. And a lot of it is generated just like the Earth from the rocky mantle. It's the salts in that rocky mantle are dissolved into the water, and that's where that salt and sulfur and everything else is coming from, just like on the Earth.
Great. Thank you. Another mystery to unsolve.
Another mystery. There's lots of mysteries here. It's remarkable we know as much as we do, but we're just scratching the surface, pun intended. Um, so again, that's a big ball of ice, and all of those lines there are cracks, and sulfurs and salts and everything else have come up, interact with the radiation from the sun, and they get that sort of tannish color. Does it have an atmosphere? That would be interesting. And the answer is, and I almost put it on here, kind of yes, but it's extremely very, 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 very thin. And this is a little surprising too. It's mostly oxygen. You go, whoa, that's pretty nifty. It's not some sort of acid or something, it's oxygen. And what happens is we feel here is that radiation coming from the sun interacts with the surface ice, with that icy surface. And if you think about water or ice, what's it made of? It's made of hydrogen and oxygen, H2O, two atoms of hydrogen to one oxygen. When the radiation hits that ice, it can break that molecule apart into hydrogen and oxygen. The hydrogen flows way up to the top of this little tiny atmosphere and more likely just keeps going because hydrogen is so light. The oxygen kind of sticks around because Europa is big enough to kind of hold on to it with gravity. So it has a little bit of an oxygen atmosphere. And it's so thin, we don't even like to call it an atmosphere. We tend to call it an exosphere. Even the moon has a little bit of an exosphere. And so this is kind of in that same boat. You definitely don't want to go stand on the surface of Europa and take your mask off and try to breathe. Yeah, not going to work. Even though it's oxygen, it's not going to work. It's way too thin. So it's kind of an atmosphere. Okay, this is what Rachel's been waiting for. Does life exist there? Boy, I wish I knew the answer to this. In the back, in my own self, I think I know the answer, but you can't. You know, it's just based on my own whatever. You need the facts. But on Earth, which we base a lot of our knowledge on, obviously, is that life has been found thriving near subterranean volcanoes and deep sea vents and other extreme environments down at the bottom of the ocean where that ocean water hits that mantle. And so you could have from the core in the middle, you could have some heat, have some volcanoes coming up, or a deep sea vent where you're getting hot kind of material out of that rocky mantle coming from the core and warming that water up and causing it to either warm up and possibly even boil if it's hot enough. And so on Earth, and this was very surprising, and really it's fairly recent knowledge, is that we always thought that the bottom of the ocean, forget it. There's nothing down there. It's just really deep, deep, dark water, and there's no light at the bottom of the Earth's oceans. And there's no way anything can live down there. But with explorations, Jacques Cousteau and all these others that have explored, we found out, whoa, no, it is teeming with life down there at the bottom of the ocean. And we call these extremophiles. They're life forms that have evolved down at the bottom of our oceans, and they live around these vents and volcanoes and extreme environments. This is the biggest indicator here that this could very, 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 very easily be happening on Europa, is the interaction between the water, the chemicals, and the heat. And it's all this down right at the very bottom of that ocean. And life forms could possibly have evolved just like it did on Earth, completely separate, independent of the sun, plants, chlorophyll, all that stuff. They completely came about on their own down in these extreme environments. And so this is a huge, huge pull to Europa to say, is the same thing going on at the bottom of Europa? There's your mystery. I'm going to show you a little video here, and this is about the Earth. It was done by the National Oceanic Atmospheric Administration, the Weather Bureau, but it was talking about what's going on at the bottom of the Earth's ocean. Now, what I want you to do is to watch this, knowing it's the Earth, but watch it put on your Europa glasses and watch this thing and think about, what if I were on the bottom of the ocean in Europa? Could this be happening there? So look at it from that perspective.
The Earth cracks open. Fluid and minerals spew from the seafloor. Water shimmers. Life abounds. We're looking at hydrothermal vents, originally discovered near the Galapagos Rift in 1977. Basically, a hydrothermal vent is a hot spring produced by underwater volcanoes or tectonic activity. But what's really cool about them is the abundance and assortment of life that exists there. It's not life like we're used to up here on the surface. It's adapted to the dark conditions of the deep ocean. Organisms that live around hydrothermal vents don't rely on sunlight and photosynthesis. Instead, bacteria and archaea use a process called chemosynthesis to convert minerals and other chemicals in the water into energy. This bacterium is the base of the vent community food web and supports hundreds of species of animals. What kinds of animals? Well, scientists on the NOAA ship Okeanos Explorer went to the rift in 2011. And here's just some of what they saw. Riftia tube worms, also called giant tube worms, which can grow to their full size of almost 5 feet long in less than 2 years. Bathymodilus deep sea mussels, which are often the first creatures to colonize the vent, and are able to survive for a short time after the vent is inactive. Serpulid, or feather duster worms, and Tevnia tube worms, which are often the food of choice for vent crabs, the top predator of the vent community. But it's not all animals down there. Researchers also saw white flocculent material erupting from the vents like a snowblower, an indicator of microbial life beneath the seafloor. And of course, there were fresh lava flows, which means the seafloor is continuing to change. And that change means there's always more to learn.
Wow. That, like I say, is knowledge that is not that old. We're just really beginning to understand the Earth's oceans and what's going on down there. And this just relates so well to Europa. I mean, oh my goodness, this exact same kind of thing could be happening down there. So that's really enticing to say, does life exist there? Oh my. It's very possible. Okay, I had mentioned earlier that exploration of Europa, we had seen the Galileo, the Voyager, etc. Here's what's coming up, and this is going to be very, very exciting. NASA has a mission that's actually being built as we speak, called Europa Clipper. ESA, the European Space Agency, is developing a spacecraft short for JUICE, is Jupiter Ice Planet Exploration, which is, it's going to explore Europa, Ganymede, Io, not just Europa, but it's Europa's part of its suite of explorations. But we're hoping to send these two new spacecrafts specifically to try to answer this question. The Europa Clipper is specifically for Europa. And so what's going to happen is Europa Clipper will go into orbit around Jupiter. It's almost impossible, just orbital dynamics, to go into orbit around Europa. So we're going to go around Jupiter. It's also some radiation issues, and I'll talk about that in a second. And then every time we go around and we go by Europa, we make sure we shift ourselves a little bit so that we end up covering the whole moon. So we'll end up looking at the whole moon, and then the instrumentation aboard Europa Clipper will be trying to get better ideas on what the ice is made of, like we mentioned earlier, how salty it is, what the more detail on these lines. And a big deal is these geysers that are coming out through this ice. We want to fly through those geysers and sniff that water. That would be massive to see what's in that water and what chemicals are in that water. That would give us a big deal in terms of is there life down there generating some of this stuff? So those are two missions coming up. The Europa Clipper is targeted to launch in 2024. JUICE are a little bit sooner than that. JUICE is due to arrive at Europa in around 2029, and Clipper around 2030. So both around the beginning of the next decade, end of this decade, to get out to Jupiter. This is a really good summary of what's going on with Europa and these two missions. And these are some of the JPL scientists that are out in that NASA facility. And this is a really good clip on them talking about Europa and this upcoming Clipper mission. This is going to be a big deal.
Europa is the most likely place to find life in our solar system today, because we think there's a liquid water ocean beneath its surface. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life.
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and its set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa, but Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region.
Kind of like when I was a kid, we had the sprinklers, and we didn't want to be too close to the sprinkler head, so we would run in and get a little water and then run back out again.
This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat, and do this many, many times until we understand Europa globally. Images from the Hubble Space Telescope tells us that Europa might be erupting plumes of water high into space. If that's true, then we could fly through those plumes with a spacecraft and literally taste it to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond.
Wow. I'm not sure if you have been that familiar with Europa in the past, but I'm hoping that this little presentation will kind of give you clues as to the importance of Europa. And this is my own prejudiced opinion. I think this is where we need to go. I mean, it's nice to go to Mars. It's nice to go to these other places, but this is where we need to go. That's me talking. That's not NASA. Anyway, for more information on Europa and Europa Clipper, there's a ton of it, just nasa.gov, and there's all kinds of information there. If you have any, if you get past the presentation and say, oh, I meant to ask this question or need some information, there's my email address, greenvillenasa@gmail. Please send me an email for any kind of questions or comments or needs. And, be glad to hear from you. So hopefully this was helpful, and I really appreciate you attending tonight. And Rachel, I did it. I did it. 50 minutes. I promised Rachel I would not get too yakky and end up being here an hour and a half. I was able to bring it in on time so that we can have a little bit of time left over for questions and answers.
Yes, and we do. We have some questions that have popped up.
Oh, good.
So not to worry, the mystery continues. We're going to ask some more questions. The first one is, how much warmer is the floor of Europa's ocean in comparison to its super ice sheet at the surface?
At the top. That's I wish I could tell you the answer to that. We feel that based on, like he was talking about in the video, as Europa goes around Jupiter, it's squeezed and twisted and everything else, and that generates basically, if you think about it, friction. And that's going to warm up that core. It's going to warm up that mantle. And that mantle then should be warmer as even with the core. And so the idea would be that the water would be much warmer down at the bottom near the mantle. And if there's actually vents, like in that video on Earth, if there's actually hot material coming out of that mantle and bubbling out into the water, we feel that it should be much warmer down towards the mantle than up towards the icy shale that's going around the planet.
Okay. The next question is, for the Europa Clipper, does adjusting the orbits around Jupiter, is it sort of like winding a ball of yarn?
Yeah, that'd be a good way to think about it. Good way to think about it. It's like to mention there that the big deal here is that if and I alluded to it earlier, you can't, like we do with Mars, you can send a spacecraft to Mars, put it in orbit around Mars, and it's taking pictures and has a good time. Can't do that with Europa or Io or even any of them, because Jupiter is putting out so much stuff, so much radiation, that if you tried to get into orbit around Europa, you might last a very short period of time and it's going to burn you up. You're just going to burn up the spacecraft. You just can't. It's just too hostile. So what you got to do, like he's saying, we're going to orbit Jupiter. I like her analogy where you run in and out of the sprinkler. You can run in and you get really wet and then run out. But if you stand there, if you stop, you're going to get soaked. Same thing, we're going to get soaked with radiation here. But if you think about the yarn, exactly right. The whole idea would be to fly by Europa, go back out towards Jupiter, adjust our orbit just a little bit, and come back into Europa and be off a little bit from where we were before, and then be off a little bit from where we were before. And pretty soon you've covered the whole moon. So that's a good analogy, yes.
Okay. See, yes, and of course, someone made the comment that they wondered why space probes didn't hang around the planets much longer.
Oh.
But now we know.
Yeah, it's the same. It's a kind of the same concept as why we have not put many spacecraft around and investigating the sun. Because the sun, of course, is the king at putting out radiation. It would just cook it. The latest thing that we've tried, and we finally have the technology to do it, is what's called the Parker Solar Probe. For more information on that, you can go to nasa.gov. That's the commercial. But the Parker Solar Probe is investigating the closest spacecraft that's ever been put towards the sun, and it has a big, giant, almost like a knight in armor back in the Robin Hood days. It has a big space shield it holds out in front of itself that's blocking that radiation from the sun. And all of the instrumentation are in very, very heavy, thick titanium thing. I mean, they had to really basically make this thing artillery safe to protect it from all the radiation. Same problem with Jupiter and Saturn. Big, huge planets, and they put off a lot of radiation. So we anything that deals with Jupiter, Saturn, you got that problem. Not so with the Earth or Mars or anything else, but Jupiter and Saturn. Uranus and Neptune also to an extent, not quite as bad, but also with those guys, you have that same issue.
Okay, does anyone else have any questions?
Any questions? Any questions in general? I'll take an opportunity to say, if you have not, you need to go out to YouTube if you have not seen the Mars helicopter fly. That is absolutely remarkable. It's as NASA calls it, it's a Wright brothers moment. It's the first powered flight of an aircraft on another planet, and we're here to talk about it. But if you go out, it's very easy to find. You just go out to YouTube and do a search and say NASA Ingenuity, which is the name of the helicopter, and there's all kinds of video out there. And you'll see it sit there and spin up and fly up into the air and come back down. It's quite remarkable. And the new rover up there is doing the same thing that we're trying to do here with Europa. It's looking for life signs. And so the rover has all the instrumentation on it to to do just that. And the landing spot was extra special, in that they landed in what we feel was a former river delta. If you think of a river delta, on any river flowing into the ocean, there's all kinds of nonsense coming down that river, silt, all kinds of stuff that's deposited on the bottom of the ocean. And so if there's life to be found, it's probably going to be found in there. So we're hoping to find evidence that there was once life alive in that river delta coming into the, basically we're in a crater, but it used to be a lake. And to plug Rachel's program, if you like, we did a program on the Perseverance rover, and it's on YouTube, on the library's YouTube channel. So you could go out, and I go into detail there of why the rover is where it is and all that stuff. So if you're interested, that might be a resource for you.
Yes, definitely check that out. Click on the science playlist. You can check it out there. And then we did get one question that was emailed to us too. How far are we from figuring out how to get a human from one planet to another without it taking quite so long?
Quite so long. Yeah, that's an excellent question. And it comes back to the magic word energy. You don't get something for nothing. It takes energy in some form or another. Right now, our biggest woomph, you might say, is chemical rockets. You see them launch off of Cape Canaveral. You see all this flame and fire and everything else. You get the most bang for the buck with chemical rockets, but it takes a lot of energy, and you can only get so much speed out of it. The big promise is what's called ion propulsion. It's already been used on the mission I like to talk about that uses this new advanced propulsion was the Dawn mission, like the Dawn liquid used to wash dishes, DAWN. Dawn mission went out and explored 2 of the asteroids in the asteroid belt between Mars and Jupiter, Ceres and Vesta, and it used ion propulsion. Ion propulsion basically uses heat either from a nuclear reactor or from the sun, solar cells, or electricity, and it heats up. It can be the fuel, and believe it or not, can be water. It could be nitrogen. It could be anything that you can heat up. You heat it up and you spit it out the back of the spacecraft, just like you do with a chemical rocket. You spit fire out the back. What happens due to physics is you go the opposite way. That's how a rocket works. Ion propulsion is extremely efficient. Chemical rockets are only about 30% efficient. For as much fuel as you're burning, you're only about 30% efficiency getting what you can out of that fuel. Ion propulsion is 90% efficient. And so what you do with ion propulsion, the big deal is it doesn't take hardly any fuel. So the biggest thing, if you look at some of the big rockets take off from Cape Canaveral, it's mostly a big fuel tank. All of it there is basically fuel. With ion propulsion, it's a minor part of the spacecraft. It weighs almost nothing. That's the good part. The bad part is that the thrust, or the actual force that it pushes, is very, very, very small. So what you've got to do is turn on your ion propulsion and just leave it on, and you get faster and faster and faster, but it's continuous. Chemical rockets, you ignite it, you burn up your fuel in 3 or 4 or 5 minutes, and you're done. Ion propulsion can go for years. And in the end result is with ion propulsion, you can actually, over time, go almost 8 times faster than you could ever do with a chemical rocket. So if we can kind of get that going, yes, we might be able to get to Mars. Say it right now, from a chemical rocket takes about 9 months. So you have to pack a lunch and take an extra bottle of water. With an ion propulsion, we might be able to squeeze that down to 6 months. But it's got a ways to go, especially with a big spacecraft. If you have people on it and you think about all of the weight, you've got to generate a lot of electricity, a lot of power, and we're just not there yet on that. So it's coming, but there's new propulsion research going on all the time within NASA to see other ways, because you'll never get away from chemical rockets to get off the surface of the earth. The gravity's just too high. You've got to have a lot of force very quickly, chemical. But once you're in space, you're, quote, weightless. Ion propulsion works like a champ, because even though it's small, it's continuous, and so you can get up to very, very, very high speeds. So it's coming. We're probably not going to see it in our lifetimes, maybe even not of our children or grandchildren, but it's obviously a subject that's under a lot of investigation.
Thank you so much. I think we've all learned a lot. The comments in the chat are coming in about how fantastic this was.
Oh, well, good.
And yes, as you mentioned, the mysteries continue in space.
Yeah, exactly. This, you do a presentation like this, and you say, "Wow, we know a lot about you." Well, yeah, but not that much. We have so much to learn. We're just scratching. So yes, we're learning a lot, but there's so much to learn and so much we don't know.
Right. Well, we thank you so much for sharing
Oh, thank
your
you.
time, your expertise, your talent with us. We always appreciate you coming to visit us at the library, and in person or virtually. We're so grateful for you.
Yeah, looking forward to the in-person events again, so we can have
Stay tuned.
Stay tuned. Yep.
We'll be doing those again soon. But thank you all for attending. We appreciate your attendance at all of our Month of Mystery events. If you missed any of them, you can check those out at greenvillelibrary.org and go to Adult Classes and Activities. On that page, you can find any of the buttons for our YouTube playlists, like the science one. That's where you'll find this one. And of course, we also have the virtual murder mystery sort of game adventure on that page as well. So you can keep mystery going for as long as you like. And of course, we always ask that you follow us on Facebook, Instagram, or Twitter. Also, make sure that you sign up for our e-newsletter. That way you don't miss these awesome opportunities like this to be able to have an interactive experience with our NASA Solar System Ambassador. So thank you all so much for attending, and we'll put all the links to everything that David mentioned and that I mentioned in this YouTube video description below. So thank you all, and have a wonderful evening. Good night.
Thank you, everybody. Have a good evening.